Most developmental scientists would agree that development is a successive and systematic change. And developmental system approach consider development as sort of interaction of various factors. For example, genetic activity, neurobiological activity, biology, culture and time, how they interact and affect development. And couple of notable series of development from the developmental systems approach standpoint. For example, one of them is a theory of Yuri Brenner by ecological systems approach, where you consider your outside environment as one of the kind of main driving forces of development, and you can classify your environment into like several layers, 5 of them. The closest level is level that it's called microsystem, that where child interacts directly with the environment. Microsystem examples can be home, school, and so forth. The second level is mesosystem, which describes how different microsystems interact with each other. For example, it can be how home environment interacts with and influences school environment. And the third level would be exosystem. Child is not directly placed into the exosystem. Example can be parents' place of work, but the exosystem still influences child development indirectly. The fourth level can be, according to Brenner, is macro level. This is like level of laws and cultural context, overall cultural context. And fifth sort of like level in the theory is chrono level, chronosystem, and that shows the influence of time. All those factors interact with each other, and the interaction depends quite heavily on time. So that's example of one theory. The other theory, notable theory, is theory of Gilbert Gottlieb, which is called probabilistic epigenesis. And the idea is here is to devise like similar levels, but those levels are kind of more internal. And levels devised by Gottlieb, first level is genetic activity, the second is neurobiological activity, the third level is behavior, and fourth level is environment, which is physical environment, social environment, and so forth. And Gottlieb argues that development is driven not by like genetic process, but by epigenetic process, that environment and gene activity constantly interact with each other, and gene activity is how different cell produces different proteins and in what quantities they do it, and how that and that influence our behavior. And the whole subject of development is very complex. It touches many different kind of sciences, and because of that it's essentially an interdisciplinary area of research. One example of using developmental system approach is, for example, how well-being of youth can be viewed. Instead of like out of context migration from one state to the other, the development in terms of like development system approach can be viewed as complex interaction between environment and the person. For example, a study of native people that live in Alaska showed complex sort of like complex kind of view how people view their well-being and success, and how it actually depends on various factors like gender. For example, girls viewed success more in terms of the academic progress and how they help with younger children, while boys view their success in somewhat different terms, in terms of what type of like vehicles or snowmobiles they can drive, which is probably something less useful for the society overall. And development system approach will also emphasize that those children can not only they're influenced by their environment, and that they view, for example, their success, it's quite specific to this physical location and place, but also how environment is also, and their context is shaped by those children as well. So there is bidirectional interaction between a person and the environment. So that's sort of one of the examples of applying developmental theory approach to the practice. And you can use it, of course, to design educational programs in an appropriate way, and also how do you drive policy in terms of policy in a state and so forth. So that's my review of the developmental systems approach.